conservation of mechanical energy and the work energy principle. In this question, a box of mass 2 kilograms is projected with a speed of 6 meters per second up a line of greatest slope of a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the box and the plane is 1/3. Use the work energy principle to calculate the distance the box travels up the plane before coming to rest. So just highlighting the key information. Now I'm going to draw a diagram. So let's make our diagrams nice and big and clear. So we know we have 30 degrees. The box starts low and it has a mass of 2 kilograms, so a weight of 2g. There is a reaction. It is moving up the slope with a speed of 6, and it travels up the slope until the speed is equal to 0. Coefficient of friction is 1/3. There's also friction, which I'm going to denote as Fr. So, to work through this, we think of it travelling a distance of x meters up the slope. Well, things that we know. We can think of initial kinetic energy and final kinetic energy. So we can work out that as it starts at 6 meters per second and finishes at rest, it loses kinetic energy. So the kinetic energy lost is equal to a half times the mass times the initial velocity squared minus a half times 2 times the final velocity squared, which gives us an answer of 36 joules. Next, as it goes up the slope, it gains potential energy. For this, we can think of it as a right angle triangle. So it goes up the slope a distance of x. It gains a height of h, 30 degrees, so h is equal to x sine 30 degrees. So the gain in potential energy. Now I'm going to take my base level as where the box started. So that means our potential energy gained is our mass times gravity times the height, which is x sine 30 degrees. Well, sine 30 is a half. Half times 2 is 1. So we end up with xg joules. I'm going to leave my gravity constant in there. And in this case, we're taking gravity to be 9.8 meters second squared. Meters per second squared, sorry. Okay, next. We need to work out the work done by friction, or the work done against friction. So, looking at friction, I'm going to resolve perpendicular to the slope. So R, going back up to the slope here, and that angle is 30 degrees. So perpendicular slope, we have R, and going in the opposite direction, we have 2g cos 30 degrees, so the component of the weight acting perpendicular, and that is equal to 0. So R is equal to, and cos 30 is equal to root 3 over 2. So root 3 over 2 times 2 is root 3, so root 3g. Now we know that as it is moving, friction is maximum. So know that friction is equal to mu r as friction is maximum. So the friction is equal to mu, which is 1/3, times r, which is root 3g, which gives us a value for friction to be root 3g over 3. Now, the work done against friction is equal to the frictional force, root 3g over 3, times the distance, so in other words, times x. Next, we can think of the whole system. So the kinetic energy lost must be equal to the potential energy gained plus the work done against friction. Let's fill in what we know. 36, potential energy gained is xg, work done against friction is root 3gx over 3. So now we have an equation which we can solve. So on the right hand side, x is common, so 36 xg plus root 3 times g over 3. So therefore x is equal to 36 divided by g plus root 3 g over 3. Now using g is 9.8 meters per second squared, gives us an answer of, on my calculator, 36 over 9.8 plus 9.8 times root 3 divided by 3, which gives us an answer of 2.3288. And although it doesn't keep going 8, that should be enough accuracy. Rounding that to 3SF, 2.33 meters to 3 significant figures. So let's just check the question. The question says to find the distance the box travels up the plane. So therefore, to conclude, the box travels 2.33 meters up the plane. So you should always finish with a sentence explaining what you found.